So we were discussing inverting and non-inverting amplifier. Okay. And yesterday we have seen for non-inverting amplifier. Okay. For non-inverting amplifier, what are the formulas for closed loop gain? So closed loop gain is given by 1 plus RF upon R1. Okay. For ideal op-amp, ideal case. And ideal op-amp means infinite gain. AOL is infinite. And A closed loop gain was equal to AOL 1 plus beta AOL for practical op-amp or non-ideal op-amp if your AOL is finite. Okay. And what is non-inverting amplifier circuit? Non-inverting amplifier circuit means you are applying voltage at non-inverting terminal, and these amplifiers are with negative feedback. So this is your RF, this is your R1, and this is your ground. Okay. Sometimes this kind of circuit is drawn like this also. This is a V input. Okay. This is my RF and this is R1. Whatever input is coming to the R1 to V naught is going to the negative. So this circuit and this circuit are same, so don't get confused. Okay, this is the same circuit. And if I push this one like this, okay, and like this, so this become same circuits. So this can be drawn in many different way, and this is a V naught, and these are the formulas. And now similarly for inverting amplifier, for inverting amplifier, closed loop gain was minus RF upon R1 for ideal op-amp case. And for practical case, closed loop gain was equal to minus K AOL. Please check it whether I'm writing correct or not. 1 plus beta A naught L. Is it the correct formula? What we derived yesterday? Karishma? Leo? Is that the formula yesterday we
Correct,
derived?
sir. Correct.
Yes, sir,
Correct.
correct.
Okay. And here you should know what is K. Beta is what? Beta is feedback. Feedback is R through R1 through RF, but it is voltage at R1. So R1 plus RF, and K is your RF upon RF, R1 plus RF. Okay, and the circuit for inverting amplifier is you're applying now input to the inverting amplifier. V input is here. This is your RF, and this is your grounded. Non-inverting terminal is grounded, so this is the inverting amplifier. Now let us understand these formulas with some example. So I'm erasing this one. So let us say I have a circuit non-inverting amplifier. Okay. Whose RF value is 100 kilo ohm and R1 value is 5 kilo ohm. Okay. Now I want to the find the closed loop gain. Okay. Calculate or calculate closed loop gain ACL. Okay. For the following cases. Number one, open loop gain is 100. Second is open loop gain is 10 raised to power 5. And third, open loop gain is equal to infinite. For these cases, I need to find the gain of the circuit. Let us find out. So first, these are finite cases, finite AOL cases, and this is your ideal. So for ideal case, the formula, first you'll see the finite cases formula. So finite cases formula, closed loop formula is AOL 1 plus AOL beta. And now we can write here AOL is 100, 1 plus AOL is 100. And beta is how much? Beta, tell me what is beta value? Beta value is R1 upon R1 plus RF, that is 5 kilo ohm. Okay, 5 kilo ohm, and this is 100 and 5, 105 kilo ohm. So this is 1 by 21. Beta is your 1 by 21. So put it the value 1 by 21. Okay. And now solve it. How much will come? So this is 100, 21. Okay. And this will become 121. Tell me the answer. What is coming? What is the answer? 20 point something. What will come? 2100 divided by 121.
$17.35.
Huh?
17.35.
35. Okay. This is the open loop gain. So this is the first case. Third case, I'm doing directly. Third case, direct formula is there. Third case is your A closed loop gain is simply 1 plus RF by R1. So this is 1 plus RF is 100 kilo ohm. And this R1 is now 5 kilo ohm. So this is 20. So this is 21. So ideal case is gain is 21. And if you have a finite gain 100, then this gain is changing. And now let us see if gain is 10 raised to power 5, then what happens? Okay, then also you can use this formula and you see what has happened for the second case. The second case, your closed loop gain will become AOL is 10 raised to power 5 1 plus 10 raised to power 5, beta is 1 by 21. And now what will become this one? 21 into 10 raised to power 5 and 21 plus 10 raised to power 5. Tell me what is the answer of this one. So if I neglect this 21 compared to this one, this is almost 21. Okay. Actually, equivalent to the ideal value. So as the gain increases, it will approach the ideal value. Here it is slightly less than 21. Something will come 29 point something. How much is coming? Okay, you can solve it easily.
20.99.
20.99. Okay. And this is almost equal to this one, 21 if it is correct. So you can see. That's why we say high value means ideal value. Now let me take same example with inverting. With inverting, what will happen? For inverting case. So inverting case, you have this minus plus, this is grounded. This is R1 is V input and this is RF. Say this is 10 kilo ohm and say this is 1 kilo ohm. And here to find the closed loop gain. Okay, find closed loop gain when AOL is infinite. AOL is 10 raised to power 5 and say when AOL is 100. So this number is given, so we'll consider it as a finite case. So now tell me what is the formula for inverting amplifier? So closed loop gain for inverting amplifier ACL is given by first case and AOL is infinite minus RF upon R1. So this will become minus 10 by 1 kilo ohm. So this will be minus kilo ohm will cancel. Kilo ohm is minus 10. Second case, the formula is A closed loop gain is formula is minus, what is the formula? K AOL plus
1 plus
AOL.
beta AOL.
Okay. So minus K is your RF 10 upon 11. This is your K. AOL is 10 raised to power 5. 1 plus AOL is 10 raised to power 5 and beta is what? R1 upon 1 upon 11. Okay. So this will come minus 10, 10 raised to power 5. And this will come here 11. 11, 11 cancel. 10 raised to power 5. So tell me what is it? This is all should be almost close to 10. How much is coming? Minus 10 divided by, okay, how much come? 1 plus 0.00011. So it will almost come 9.99 only. And now you can check for the third case. What happens in the third case? It will be slightly different. Whenever gain is less.
ये कैसे लिखा है इसमें?
Huh?
How you write this K?
K is what? K is your RF upon R1 plus RF. Okay, so 10 upon 11. And beta is what? Beta is your R1 plus RF. Put the values and right. And the third case, when your AOL is 100, third case, A closed loop gain, formula this one minus K. K value will not change, 10 by 11. This is 100. 1 plus 1 by 11 and 200. So this become minus 1000. And this is 11, 11 cancel. 1, 1, 1. How much is coming? Almost 9 will come. 9 point something.
9.1.
9.1. 1. This is for कैसे ये फार्मूला लगाना है थोड़ा उसके लिए बता दिया है. ठीक है, तो आपको हमेशा यू ऑलवेज सी वेदर द ऑप एम्प आइडियल है कि नहीं है. आइडियल है तो सिंपल फॉर्मूला लगाना है, अगर फाइनाइट है तो फिर ये फॉर्मूला लगाना है. ओके, एंड नाउ विल सी सम मोर क्वेश्चंस. I'm releasing. Have you done, everyone? This is a simple formula. You can do it yourself. I'm just revising the concepts so far. Whatever we done before proceeding further, whatever we have done, that we should concrete that one. Okay. So now there's one more question. Minus plus. This is R. This is 1.5 volt. Here you have 100 R. This is your grounded. This is 15 volt. This is minus 15 volt. Okay. So it says, question says, what is the magnitude of V0? Okay. What is V naught magnitude in this case? Tell me, what is the magnitude? कितना आएगा? योशिता कितना आएगा आंसर?
सर 30 वोल्ट।
30 वोल्ट। ये कौन सा इन्वर्टिंग है कि नॉन इन्वर्टिंग है?
इन्वर्टिंग।
फॉर्मूला क्या लगा रहे हो?
ओके ओके सर।
दीपक कितना आएगा?
One second, sir. Solve
Sir,
कर रहा हूँ.
हाँ.
R value is what?
R value is not given. R and 100R. I'm asking only. Okay. You are you can solve. So you can solve. Everything is given. V input is given na 1.5 volt. So what is the value of V naught? Tell me. Minus RF upon R1 into V input. RF is 100R. And this is R into V input is 1.5. RR cancel. How much is coming? Tell me.
150.
150. So is this the correct answer or wrong answer? Is this the correct answer or wrong answer? Leo,
150 आएगा सर मॉड लेना.
this is the wrong answer. Okay.
Minus
Why?
15 only, right? Sir?
Arey, 150 cannot come, yaar. This is a 15 volt. That's why I'm doing these problems. So
Okay.
that whatever we learn, that concept you should do concrete. Okay. Out cannot go beyond your VCC. That is saturation property. That we learn the first thing. Saturation property. My V naught can be only between greater than plus VCC. So it's coming now. Since input is here, it is grounded. Input is applying. You're applying here. Something you're applying here is coming here. So V naught will be what actually? Which V naught saturates. Saturates. So saturates value will be V naught will be minus 15 only. And the answer question is what is V naught? So V naught will be only 15 volt. This is V plus, which is grounded. This is the V minus. Okay. So this will be 15 volt. Now tell me what is the value of B minus here? What is the value of B minus? Tell me. Who will tell me the value of B minus? दीपक कितना आएगा B minus का वैल्यू? देख के बताओ. That means I am asking question whether V minus and V plus are same or not. That is we call na virtual ground concept.
0.
But here it is 0 or it is not 0 in this particular question. So here, because whenever output saturates, okay. See, actually, if it is ideal, it's not saturating. V minus V plus should be same, but it is not. It is going beyond the saturation. It's coming in saturation. So a virtual ground concept VGS is not applicable when V naught saturates. Carefully see the graph. Graph says this is the graph. This is the VID. This is what? V naught. So VID is 0 only in this region when it is not saturating. Here it can be anything. So VID is what? VID is almost 0 only when it is not saturating. That is V plus equal to V minus almost equal to only true when you are far away the saturation. Once you come in saturation, VID minus VID is either positive or VID is either negative. That means the V plus and V minus are not same. So here V plus is greater than V minus, and here V minus is greater than V plus in this case. So only near to this region, your VID, VI plus same. So here, because it is saturation, so the VI is not equal to V plus. So V plus is 0, but VI is not 0. Now we have to calculate the VI value. Let us find the VI value. Calculate the VI value, V minus value now. So if I want to calculate now, V minus value, so I can write here. Here no current is going. Always see here no current is going. So this is current coming, is going here. So 1.5 minus V minus upon R is equal to V minus V naught upon 100 R. This R cancels. Okay. Now solve it. How much is coming? V naught value you already know. 15 volts. So 1.5. So this is say 1.5 minus V1, and this is V1 minus 100 minus V naught upon 100. So here V minus upon 100 plus V minus, I'm setting this one here, and this is now 1.5. V naught is 15 upon 100. Okay, solve this one. So this is 101 V minus is equal to 100 multiplied by this one. Sorry, this is 100 will come here. This is 150 plus 15, that is 165. So V minus will be 165 upon 101. Tell me what is the value? $165 or 135. V naught value is V naught value is 15 or minus 15. Magnitude is 15. This is a minus 15 actually. Okay. So when I put the value of this one, V naught, this is minus 15. I have put this one. I bring this one here. What is value? You have to put, okay. So this will come basically this one, 135, not this one. V naught is minus 15. Minus 15, and this will come 135, and 135 divided by 101. How much is coming?
1.33.
1.33, because V naught magnitude is 15, but I'm using V naught as minus. So this will be 1.33. Please correct it in the calculation. So let us do one or two problem more. The next is your, now we'll do some more applications. So it is an amplifier. Now using this amplifier, we'll add the signals. Okay, summing amplifier. Summing amplifier. Now what is summing amplifier? It is used in the inverting configuration. This is minus, this is the plus, and say here we are applying more than one voltages. So this is V1, V2, V3. So this is R1, R2, R3, and this is grounded. And here you have V0. Here you have a RF. Okay. Now you want to find out what is the value of V0. Tell me how to do this problem. How can we do this problem? Tell me. This op-amp is ideal. So op-amp is ideal means now this is ground, this is also ground. Okay. Now either you can apply superposition principle because you have so many voltages here. You calculate voltage of here because of this one. Either you say I have, first I will do the using KCL. So say I1 current is coming here, I2 current is coming here, I3 current is coming here. So here total current is coming I, and this current is here, no current is going, the same current is going here. So I can say applying KCL at this node, I can write I1 is equal to I2 plus I3 is equal to I. Now what is I1? I1 is V1 minus 0 upon R1. I2 is V2 minus 0 R2, and this is V3 minus 0 upon R3. And similarly, I can write this I is 0 minus V0 upon RF. So my V0 formula will become what? V0 formula become minus RF upon R1. Okay. V1 minus RF upon R2, V2 minus RF upon R3, V3. And this form, this is nothing, this is a superposition principle. I can write this is equal to say minus V01 plus say minus this is equal to V01 plus V02 plus V03. Now what is V01? V01 is voltage, output voltage V0 due to source V1. Similarly, V02 is V0 due to a contribution to V0 source V2, and similarly V03 is contribution to V0 due to source V3. Now I can do the same problem use superposition principle. I assume these are 0. This 0, this 0, only this is present. So this is present means only current is coming from here to here. Okay, so I can say V1 minus 0 upon R1 is equal to 0 minus V01. If I say this because of this one, your source is V01. So V0 will become what? V0 will become simply minus RF upon R1 into V1. Similarly, V02. Similarly, V02 will be minus RF upon R2 V2. V03 will be minus RF upon R3 upon V3. So this is either you use apply the KCL or you apply a superposition principle. You will reach to this conclusion. You can come here. Is it clear?
Yes.
Okay. So let us now solve one or two problem more based on this formula. I'm rubbing this one. Say I have one more problem. I think this problem came in your TFI exam. Say I have a say resistance. I'm applying a say 1 volt. Here is 2 volt. I'm applying 2 volt, and here resistance is R by 2. R by 2, and then applying 3 volt, and here you have a R by 4, and you are keep on going like this. You have NB voltage, NB, and here you have resistance R by N. Okay, and this is going here. And now you want to find what is the V naught. Calculate V naught. What is the V naught? तो एक्चुअली इन क्वेश्चन में RF पूछा था, हम ऐसे सॉल्व कर लेते हैं, फिर RF ही निकाल देंगे. So this will be what? 1 volt, 2 volt, 3 volt, 4 volt. Okay, and say V naught is 1 volt. Okay, if I say V naught is 1 volt, then what is the value of RF? In this question, if I say V naught is equal to 1 volt, then find the value of RF. Okay, so let us first write what is V naught using superposition principle. So V naught will be what? It will be minus, V naught is minus 1 volt. Minus 1 volt. Now V naught will be what? Minus RF upon R1. That R1 will RF will take common. So 1 by R1. R1 is R into tell me 1 volt. Yes or no? Minus RF by R1 into first input, then plus, tell me, 1 by R2, 1 by R by 2 into 2, okay, 2 volts. Then I have 1 by R by 4, okay, 1 by R by 4 will become what? RF by R by 4 into 4. And similarly, correct or not? And then it will come, keep on moving like this, 1 by R by N into.
सर क्वेश्चन में तो 3 वोल्ट पे R by 4 है.
हाँ,
क्वेश्चन में 3 वोल्ट पे R by 4 रेजिस्टेंस है.
तो यहाँ पे 4 कर दो फिर होता है.
सो फिर 3 वोल्ट वाली रेजिस्टेंस नहीं है.
भी आपको भी ऐसा है 1 2 4 16 ऐसे चलता जा रहा है. ठीक है, ऐसे कर दो, ऐसे कर दो,
ओके सर.
ऐसी टर्म्स कर दो और क्या. तो 3 वाली भी आनी चाहिए ना, 3 वाली भी आनी चाहिए. 3 वाली भी, अगर 3 वाली भी कर दे, 3 भी कर दो, चलो 3 भी कर दो, 3 भी कर दो, सो 3 भी कर दो, 3 3. अब सही हो जाएगा. ओके, नाउ व्हाट विल बी V naught? सो V naught will be minus RF, and this question, if I take R also common, this is 1, that is 1 square, this become 2 square, this become 3 square, and it is keep on moving, and this become N square. volts. Okay, and now you can tell very easily what is the value of RF. This is a volt. Okay, now this is the -1 volt. So RF is
Sir, I didn't get the second line.
which one? This
Uh,
one.
the denominator is R by 2 or R by 3.
See, this is R by 2, R by 3, R by 3.
Okay.
So this one 2 square, this become 3 square. Every term is becoming square, na? If we now will come 1 by R4 into 4. Resistance are like this, na? This is 1 volt, so you have R. If you're 2 volt, you have R by 2. If you're 3 volt, you have R by 3. If you're 4 volt, you have R by 4. So RF by R1, this is the R1, R2, R3, R4 multiply by V1, V2, V3. Are you getting the formula or not?
Got it, sir. Got it.
So now what is the value? Tell me. This is a -1 volt. So minus cancel. So RF become R upon this is 1 square, 2 square plus 3 square up to n terms. So R become, what is the sum of this one? Tell me. Anyone remembers what is sum? This is a GP, na? What is square of natural numbers? What is sum? 1 square plus 2 square plus 3 square n square is equal to n plus 1. Sum of this one 2n plus 1 divided by 6. Is this formula you remember or not? So this will become now 6R n upon n plus 1 2n plus 1. So this problem came in your TFIR. You can check this formula. Okay. Let me do some more problems. I'm erasing this one. Okay.
Okay.
Anyone has a doubt? Leo.
No doubt, sir.
So say similar kind of problem I'm taking. Instead of now summing, I'm doing it non-inverting. Okay, so this is R1, RF, this is V0, and this is grounded. And here I'm putting some, say, some resistance R1. I'm putting now equal resistance, say R, R, R. And here I'm putting, say, V1, V2, V3. And this is going as a input here. Okay. Here some input is going, say this is V input. Or it's not given, but something is going here. And that, so what is the formula basically? Non-inverting formula. So non-inverting formula is non-inverting amplifier. The formula is V0 equals to 1 plus RF by R1 into V input. So this is RF R1 given, only you want to find what is V input here. Okay. So let us say here This voltage is V input. Now, how can I write? Say a current is coming, say I1 here. A current is say coming I2 here. Say current is I3 is coming here. So nodal analysis, I am finding what is the voltage here. In this side, current is not going. I plus is 0. So this current I is coming and this is 0. So I can write I1 plus I2 plus I3 equal to 0. And now I1 become what? I1 become V1 minus V input, or you can write also V plus also, okay? V input or V plus, whatever you want. So V1 minus V input upon R, V2 minus V input upon R, and V3 minus V input upon R equals to 0. So what is the value of V input? So if so 3 V input will be equal to R will be 0. If you take common, it will be V1 plus V2 plus V3. And V input will be V1 plus V2 plus V3 by 3. Just put it value here. This will give you the V0. So V0 will be your 1 plus RF upon R1. So V1 plus V2 plus V3 upon 3. So op-amp questions are very simple. Only you have to remember some properties. If it's ideal, these points are same. And second thing, no current is going in the inverting terminals. That you have to remember. You should know some superposition principle or nodal analysis. Now, the same problem you can do with superposition principle also. I have done the nodal analysis. Okay, this voltage was unknown. So incoming current equal to outgoing current. Okay, incoming current equal to outgoing current. At this point, I will is this node incoming currents equals to outgoing currents. So always you can use this one. If you don't want to use this one, you can do superposition principle. So then you can find what is voltage here. Because of this one, what is voltage here? Because of this one, what is voltage here? Because of this one, what is voltage here? Accordingly, you can find what is V01, V02, V03, and later you can sum. That's way also you can do. Okay. So using superposition principle, it is your homework. Okay. Superposition principle means this will be present, but this will not be present. This will be ground. This will be ground. Then what is V input 1 here? And that will give V01. Similarly, the second time you do this one, and in this way also, you try to solve and try to get this answer. This is your homework. If you're not getting, you tell me tomorrow, because you will learn both the methods, superposition as well, nodal analysis in the op-amp. Somewhere nodal analysis will be easy, somewhere superposition will be easy. Okay. So this was your summing amplifier. Now let me do difference amplifier. Here what I'm doing, I'm summing. Now we will subtract. Okay. So what is the formula for difference amplifier? Or subtraction? How much time is remaining? I'll take 1 minute break. Welcome. Now let us say difference means now you will apply out that signal at both the terminals. So this is your minus, this is your plus. Here I'm applying say V1, say this is R1. So this is RF. And say here also I'm applying signal, and this is say this is R3. So this is R4. You can say this is R2 also instead of this one, and this is your ground. So V1. So basically you're applying voltage at both the side. Now tell me how to do this problem. Can anyone tell me?
Virtual ground.
Virtual ground.
Virtual short.
Virtual short is not there. It's not short there. So I can find a voltage here. So either you can do superposition principle, assuming this is 0. If this is 0, automatically this becomes ground. Nothing is there. And you can do inverting amplifier one time. You can, so superposition principle say what? V0 will be V01 plus V02. Okay. Now V01 is what? V1 is due to V1, and V02 is due to V2. So I can directly write what? I can directly write V0 equals to, because of this one is will be minus R2 by R1 into V1. When I'm putting this 0 volt, here also coming 0. That is, it is grounded. No current is flowing, no drop is there. So this voltage is 0. So only because of this one comes this one. And now second time when I make this ground, only for because of this one, that will be, tell me what's the formula? 1 plus
R2 upon R1.
1 plus R2 upon R1 into what?
V V2.
Voltage here. Voltage here. What's the
V2.
voltage here? Oh, not V2.
V positive.
V positive. V positive. And V positive value, what now you can find out. So V0 will be minus R2 by R1 into V1 plus 1 plus R2 by R1 into V plus is what? R4 divided by R3 by R4. Voltage division
Into V.
into V2. So this is the formula. Or directly you can write KCL also. Then also you can come to this formula. KCL we'll see later. This is superposition principle. KCL means this point is here, V plus is there. So V1 minus V plus divided by R equal to V plus minus V0 divided by R2, and V plus value you can put this one. What is the V plus value here? V plus value is R4 upon R3 plus R4 into V2. Now we can solve it further. V0, I can write minus R2 upon R1 into V1, okay, plus 1 plus R2 by R1 okay. And now this is, I can write this as a 1 plus R3 by R4 into V2. Now why I'm writing like this? If you have been given the ratio, if you have been given ratio that your R1 by R2 is equal to R3 by R4. If this ratio of this one and this one is equal, then you can solve it further. Then you can write V0 will be what? V0 will be this R2 by R1, keep it like this, into V1 plus this R2 by R1, keep it like this, R1. You can change this one. R3 by R1 will be 1 upon R1 plus R2 into V2. So let us see what we can get by solving this one. So this V0 will come now R2 upon R1 plus this will become R1 plus R2. R1 plus R2 divided by R1, and here also same thing, R1 plus R2 divided by R2 into V2. Note down. See, this is special case. Actually, our answer is up to here only. But if these ratios are given, then we can simplify it a little bit more, because I want to write this formula in particular form. Tell me, what is the formula now? So this will cancel out. So this will come minus R2 upon R1. Sorry, V1 is also there, V1. And this become R2 by R1 V2. And now my formula will become V0 equals to minus R2 by R1 is V2 minus V1, subtraction. And if I take R1 equal to R2 also, then this V0 will be simply what? V1 minus V2 minus 1. So this is this I want to do. So subtraction V1 minus V2 will come here. If this formula and these conditions are satisfied, you can do subtraction, difference. You can create a difference of two signals.
Sir,
Tell me.
sir, if you take minus R2 upon R1, it will be V1 minus V2, sir.
This is what? I take minus common, na? So minus common V1 minus V2. V1 minus V2, and this will become later case V2 minus V1. If you take R2 are equal to R1, V2 minus V2. So basically, signal you want to always from plus to minus, na? Plus to minus. V2 minus V1. Here to here you want. So V2 minus V1. No. At least some more problems. Tell me what is V0? How to find V0? So because it's the ideal op-amp. This voltage is what? Plus 4 volt. So this will be what? Plus 4 volt. Okay. And now you can directly write simple, see the simple question. 6 minus 4 divided by 4 kilo ohm. Okay, current is not going here. So this minus equal to 4 minus V naught upon 10 kilo ohm. This cancels out. So this 6 minus 4 is 2 by 4. 4 minus V naught upon 10. This goes 1 time 2 and this goes 5. So 4 minus V naught equals to 5. Correct. So how much will come V naught? Tell me. So V naught will be minus 1 volt. So this way you can simply solve the problems. Now let us say if slightly different problems comes, how to solve. If this problem is clear to everyone, Yoshita?
Yes, sir.
Okay. So op-amp is very simple. Problem is very simple. If you do minor things, the conceptual thing you keep in mind, then every circuit you can solve very easily. Now let us say I'm giving you one more problem. Minus plus and here one R is there. This is grounded and this is 10 kilo ohm and this is a V naught. Okay. And now we want to find what is the value of V naught. This is 10 kilo ohm. Okay. The question, what is the basically we need to calculate? V input is, you want to, so it is given question may V input. It is given V naught upon V input. The value is given. The value is minus 12. Okay. So find the value of R. Find the value of R. That would calculate. This is given. Tell me how to do. So ideal means first thing, this is 0, this is 0. So you know this current, but you cannot find this current because you don't know this voltage. So say this voltage is Vx. So now you want to find this voltage and this voltage. Two nodes are unknown to you. Just apply nodal analysis. Let us first find Vx. Find the Vx value. How to find Vx? So first thing, let us say this one. First thing, your V input minus 0. This is equal to 10 kilo ohm. And this is equal to what? This is equal to 0 minus Vx upon 10 kilo ohm. This cancels out, this cancels out. So this gives me Vx is equal to minus V input. This is the relation number 1. Now, second relation I can find. Okay, say this current is outgoing, say this current is outgoing, say this current is incoming. because I'm already solving like this. Or you can say this is also outgoing, no issue. So now what I can write, if you want to find Vx, so incoming current equals to outgoing current. So incoming current is, I'm saying this one, 0 minus Vx upon 10 kilo ohm is equal to what? Is equal to outgoing current Vx minus 0 by R, Vx minus V naught upon 10 kilo ohm. Okay. Now you can solve this one. You can find the value of R, and now you can put Vx is equal to minus V input. So this will become plus V input by 10 into 10 to the power 3. This will become minus V input upon R, and this become minus V input minus V naught upon 10 into 10 to the power 3. Solve this one. This value is given. Use this value and solve this one and find the value of R. Bring all V input this side. So what will become? V input 10 kilo ohm plus V input upon R. Okay, and then plus V input upon 10 kilo ohm equals to minus V naught upon 10 kilo ohm. Okay. Now you can take common this one, R into 10 kilo ohm. 10 kilo ohm is common. So this will become only R. This is 10 kilo ohm plus here R. V input is common. And this is minus V naught 10 upon 10 common. So this will be cancels out. Okay. And now V naught is given this one. So minus 12, this become plus 12. So you will have a R plus 10 kilo ohm, 2R plus 10 kilo ohm, 2R plus 10 kilo ohm. This is R and this become 12. So this become 12R. Okay.
Sir, the second line, I didn't understand the second line. The Vx by 0 minus Vx by 10 into 10 cube.
This one, okay. Then
Okay, then उसके बाद इसको V input हम लोग लिख रहे हैं वो जगह समझ सेकंड लाइन मुझे समझ में नहीं आ रहा है.
वो यहाँ से निकाला ना हमने, यहाँ से निकाला ना. अभी आपने प्रूव तो किया ना, V input is equal to minus V input. we have प्रूव ना.
हाँ.
तो वही रख दिया यहाँ पे, बस V की जगह माइनस V input रख दिया इसी इक्वेशन में. ये इक्वेशन क्लियर है ना.
पहला वाला इक्वेशन का जो वैल्यू है वो यहाँ पे पुट कर दिया है.
यहाँ पुट कर दिया.
ओके.
So this become 10R is equal to 10 kilo ohm. So R will come 1 kilo ohm. Answer. Check it up, calculation. Let me check the answer. R is 1 kilo ohm. Yes. Is that problem is clear to everyone? अगर clear नहीं है तो बताओ. I'll give one more problem, similar kind of problem. Then you have to do that problem. Okay. Karishma, is that clear?
यस सर
V
पर
naught.
एक और प्रॉब्लम दे दीजिए
हाँ, करवा रहे अभी। इसमें भी बहुत सारी करवाएंगे अभी तो। So say you have this is minus plus. Okay, this is R. Here I am applying V input. Okay, V input. And V input is 2 millivolt. And here I am putting same R. Okay, here one more resistance R. This is grounded. And here one more resistance R, which is directly coming to the V naught. Solve this problem. Tell me what is the value of V naught now. Exactly same problem. Solve this problem.
Is it 6 millivolt?
6 millivolt, yes. Minus 6.
Yes, sir.
That's correct. So again, this is 0, so this is 0. So I can write directly V input minus 0 upon R is equal to 0. So this is Vx. Okay, 0 minus Vx upon R. Again, here Vx is equal to minus V input, same thing. And now I can write a nodal analysis here. So Vx, say this is incoming, this is outgoing. So incoming is 0 minus Vx upon R. And V input is what? 2 millivolt. So Vx is minus 2 millivolt. Directly you can write the equation here. So 0 minus Vx R, Vx minus 0 upon R, and then Vx minus V naught upon R. R cancel. Okay. So V naught is what? V naught is this 2Vx, 2 or 3? 3. Px plus Vx and then plus 3Vx, 3, and this is minus 2 millivolt. That is minus 6 millivolt. Okay, so we'll stop here. Tomorrow we'll learn some more concepts and more problems. Thank you.
थैंक यू सर